Hi, my dear students. This is your Murali Krishna. This is my fourth video in the chapter Set theory for 11th class Cbse mathematics students. In this lecture, I am going to explain about different types of sets which we are going to have in this chapter. So the lesson is different types of sets. In this chapter, we come across number 1, empty set. Number 2, finite set. Number 3, infinite set. Number 4, equal sets. Now, please note down. Now, I will explain set by set. Empty set. The name itself is telling that this is empty. Empty set means the set which doesn't have any element. So, what is the definition? The set which have no elements is called empty set. Now, this empty set is also called null set or void set. You can call this as either empty set or null set or void set. Now, in most of the textbooks, the empty set is denoted by symbol for empty set is recast by. So the empty set is denoted by the letter pi. Or you can use an empty curly brackets, or we can use empty curly brackets, like just either you can use the letter pi or you can use curly brackets. That means pi is same as, and remember one thing, we cannot write writing the symbol inside the curly bracket is wrong information, wrong expression. For empty set. Please note down, I am going to discuss some examples about empty set. Set, let's say A is equal to x such that x is the student of 11th class and 12th class. I have student. So the set gets X is a student of 11th class and 12th class. That means I need those students who are studying 11th class as well as 12th class at a time. So which is not possible. So therefore this is the empty set. So in this set we don't find any element. Number 2. Let V is an element. X such that X belongs to Q. That means X is a rational number and X square minus 2 is equal to 0. That means we want all those rational numbers which are solutions of this equation x square minus 2 is equal to 0. Now, we know very well x square minus 2 is equal to 0. This implies x square is equal to 2. This implies x is equal to plus or minus root 2. Since root 2 is an irrational number, therefore root 2 cannot be element of this set. That means in this set no elements. So this is also an empty set. Next example. Let us see X such that X belongs to natural number and X is less than 5 and X is less than 7. I want a natural number which is less than 5 and more than 7 at a time simultaneously. Now if you observe natural numbers 5, 4, 3, 2, 1, 6, 7, 8, 9 and so on. Now if an element is less than 5, it cannot be more than 7. Therefore, elements in this set are not possible. Therefore, this is also empty set. Please. Next set in our list is finite set. First of all, I will write a definition on the board. Definition. The set which contains finite number of elements. Is called finite set. Now, in this set, we can count the elements as well as we can complete the counting also. Please try to understand. We can count the elements. That means how many elements are there in this set. Clearly, we can mention. And as well as we can complete the counting also. For example, we have let A example. Let A is the set contains A, E, I, O, U. Vowels of English alphabet. In this set, I have 1, 2, 3, 4, 5. 5 elements are there. So here the number of sets is finite. The number of elements is finite. We can count 1, 2, 3, 4, 5 and we can stop the counting also. So such sets are called finite sets. Again, a finite set contains a finite number of elements. And second example, we can have let B is a set such that X such that X is a prime number. Prime number less than 10. X is a prime number less than 10. Now, let me make a list of elements of this set. 2 is a first prime number, 3, 5, 7, and 11 is the next prime number, but which is more than 10. We don't want that. So, this set contains 4 elements. So, 4, a finite number, so this is a finite set. Next one. Number 2. Number 3. Let's see. X such that X belongs to Z and X square plus 3X plus 2 is equal to 0. That means I want those integers which satisfies this equation. Now x square plus 3x plus 2, you have x square plus 3x plus 2 equal to 0. So this is x plus 1 times x plus 2 is equal to 0, or x is equal to minus 1, x is equal to minus 2. So this set can be written as minus 1 and minus 2. This set contains 2 elements, which is a finite set. Our next set is infinite set. So what is infinite set? The set which is not finite. Is not infinite. Is not a set which is not finite. Is called infinite set. That's all simple. So the example. So the definition. The set which is not a finite set is called infinite set. Infinite set. Now here, in this infinite set, sometimes we can count the elements, but you cannot finish the counting. I can repeat. In the infinite sets, you can count the elements, but you cannot finish the counting. We can have another type of infinite sets also. In that set, even you cannot count the elements. Now, the present lesson in this chapter, you have only those the sets in which elements are countable, but you cannot finish the counting. Now, I will come to the next concept later. So, in this one, for example, I have A. Sorry, I will go for N. N is equal to set of natural numbers x such that x belongs to N. Natural number set. So here you can have a list of elements 1, 2, 3 and so on continuously. You can have one more example. Integers. That is 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on continuously. Or we can have one more example. That A x such that x is a prime number. So far, no one could find which is the largest prime number. Therefore, the set of prime numbers are continuous, or the set of prime numbers are infinite. The fourth set in our lesson is equal sets. When do you say the two sets are equal? Colloquially, suppose say, for example, let A and B are two sets. Let A and B are two sets, are said to be equal. Said to be equal if x belongs to A, then x also belongs to B, as well as x belongs to B, then x belongs to A. That means whatever elements you find in A, you have to find same elements in B also. Then the two sets are called equal sets. Now, for example, I take A is equal to A, E, I, O, U. Set of words of English language. I write B is equal to, say, I, O, U, E, A. Now, if you observe carefully, whatever element set in A contains, you can find the same elements in B also. But here, order is not the same. Therefore, to be equal sets, it is enough to have same elements, but the order is immaterial. So, again repeat, equal sets means A and B are said to be equal sets. If the set A contains whatever elements you can find in A, you have to find same elements in B also. Then they are called equal sets and denoted by A is equal to B.